This next video will be much shorter, I promise. So we're going to do maintaining significant figures when adding and subtracting. This one, keep this separate in your brain because the rule is different. Okay, multiplying and dividing significant figures, super nice and straightforward. Adding and subtracting, it's going to be precision. What it is that the number of significant figures in the answer is not limited by the number of significant figures in the question. It's limited by the least precise value. So let's just take a minute and do a little review to see if you know what I mean by precision. So for example, if I give you a number like 800, what level of precision does that number have? Well, it's precise to the hundreds. 820 is precise to the tens. 822 is precise to the ones. 822.1 is precise to the tenths, or often people will just be like 1 decimal, right? 822.14 is precise to the hundredths, or 2 decimal places. And then 822.123 is precise to the thousandths, or 3 decimals. So if you have a question where there's a number precise to the hundreds, you can't be more precise than the hundreds. That's how this works. So for example, if I look at these 3 numbers, this number is precise to the hundredths, okay, or 2 decimal places. This one's precise to the tenths, or 1 decimal place. And then this one's precise to 3 decimal places. Well, because we have this guy that is only precise to the tenths, I can only answer to the tenths. It does not matter significant figures. So adding and subtracting, the reason they can't use significant figures is, if you have a value like 101.25 and 3,536.2, you can't say sig figs because you want the 101 to add, but then you don't want to be more precise in your measurement. So like if these were all using the same ruler, they'd all be to the same decimal places. But maybe this was one ruler and this was another ruler and this is a different ruler. And this is obviously the least precise ruler. You can't answer to more precision than that guy. Does that make sense? Hopefully. I do that much better in person. So 2 more examples. So if I have this guy that's precise to the thousandths, hundredths, and tenths, then I'd be limited to the tenths, right? So it's the precision that's limiting my answer. This one I have hundreds, hundredths, and tenths, so I'd have to be precise to the hundreds. It's kind of weird. Nobody likes this rule, and lucky for you, we don't use it a ton. Usually this rule will happen if you're adding 2 things kind of before you put it into a calculation. So it's good to know. We use it a bit more in chemistry than we do in physics, but it's a really good rule to know. So just like multiplying and dividing, I'm going to first off start by plugging things into my calculator. So 1,247 plus 134.4 gives me 1,381.4. Now let's look to the rounding. Again, it's precision. So this guy is precise to the ones and this one to the tenths. So I can only go to the ones. So that means that I'm rounding this 1. Because the number next to it is a 4, it's going to stay the same. And I'd say 1,381. Okay, let's look at this next one. Again, plug it into your calculator. 3.862 minus 1.2 gives me 2.662. This is precise to 3 decimal places. This one's precise to 2 decimal places. You'll notice that I switched from thousandths and hundredths to 3 decimal places and 2 decimal places because I just find it easier. So now I can only be precise to 2 decimal places. So I'm going to round the 6. Because the number next to it is a 2, it's going to remain the same and I get 2.66. So same precision, question and answer. Same precision, question and answer. Okay, you give these next 2 a try. 1,200 plus 768 gives me 1,968. This guy is precise to the hundreds, and this guy's precise to the ones. So I can only go to the hundredths, which means I'm rounding the 9. Ugh. Why did I ask this question? I guess I'm going to have to do scientific notation. So if you think of this, if I want to keep it precise to the hundreds, I'm actually going to have to write this as 2.0 times 10 to the 3. Right? That's the only way of keeping it precise to the hundreds, because otherwise I would write 2000. But then how do I show that it's precise to the hundreds? So to show that it's precise to the hundreds, I can write it as scientific notation. Tricky one. Sorry about that. Okay, next one. We've got 5,674.02 plus 63. So let's plug it in. 5,674.02 plus 63, which gives me 5,737.02. This is precise to 2 decimal places. This is precise to the ones. So I can only go to the ones, which means I'm rounding the 7. And so I'm going to keep it as a 7 and put 5,737. And that's as tricky as we go with these. So these are hard and it's kind of complicated, especially when I ask a question like C. But this is as hard as they will get. I say that because we used to do adding and subtracting in scientific notation, and it was kind of a nightmare for my brain. So this is as hard as this will get. Awesome.